around, maybe make some notes of who's here, and then I'll update this attendance. I think Gregory did a good job of updating notes from the last meeting, so either Gregory or someone else can make a list of who's participating in the meeting, and we'll kind of write that down for each meeting. So I want to keep going back to weekly schedule because I know it's like a moving target at each school. We'll talk a little bit about skills overview, school updates, individual stuff, and then really most of this is just going to be about design, where we are. I know Soma wants to present some things, and then likely we'll get back into the CAD stuff that we just looked at. So weekly schedule, Lamar is still mostly Tuesday, Thursdays is what I can tell is works best for the students. We might add Friday if really necessary, especially when things get busier later on in the season. And then obviously Saturday, we had our first big Saturday meeting, which was a huge turnout, really good start of the season. And then Westside is Tuesday, Thursday, but you definitely want to check with Mr. Resendez about the schedule because I think he's got some conflicts. So make sure you guys confirm that before you plan to stay. For just this week, I think there's some conflicts because of the holiday on Monday. And then Carnegie is doing Tuesdays and Fridays. I actually went to their Friday meeting this past week, and it was a really good turnout at Carnegie. Not doing as much FRC, but it's still good to see all the students. Eventually, they'll get there. So. Skills overview, programming, it seems like we've had from the update, we had a bunch of people installing the WPI system, the game tools on computers. I think we had at least a handful. If you haven't done that and got it running on your computer and you want to do programming, just do it when you have some time. It's takes a little bit, but definitely worth it, and it'll help you get up to speed on how programming works, even if you're not a serious programmer. CAD, I know some people have been doing some Onshape. Sid has obviously done a lot of Onshape things, but other people need to catch up with tutorials and start opening up things that Sid has worked on to make sure that you understand it, because it's going to be a lot to catch up on there. And then tools, I saw some people using a drill press on Saturday. That's awesome. I think we're going to do something where we start having more documented safety, especially when you start using more complicated tools. And then I think on the roster, we're going to start having a column that says, which tool have you been checked out on? And we probably need to have somebody to kind of keep track of that so we know everybody feels safe using certain tools. I don't want to go into great detail about it, but we've had some incidents over our history of people getting injured using tools. So we want to avoid that. And maybe in the safety guide, I'll kind of do a quick summary of that so you guys can all read the details to make sure you know how to never get in that situation. So school updates, Lamar has got the wooden mock-up. I think we started that on Saturday, where Carl and Chris Ehlers brought the wooden scoring area, and it got assembled somewhat at Lamar, and I think it'll be finished pretty quickly here that we can practice scoring. And then they're programming their 2022 robot to the 2023 code. Westside is doing some swerve drive programming. I think someone's going to kind of own that and take over programming for swerve. And then they're also looking at getting their 2022 robot up to the 2023 code. So we'll have all of these robots running the new year code, so we can start testing things like April tags and other details all on this new code base. And then Carnegie has the 2013 robot. They might put the RoboRio on it, but they're definitely going to put like a Vex Cortex and just get some practice with FRC and the electrical on FRC. Everybody has a role. I don't have the roster completely filled out, but I'm working on it. So here's an example of the roster. We have people from Carnegie, Lamar, Westside, and then I'm going to try to update what category tasks they're working on and their specific task, and I'll try to get this more updated with a lot more details and make the roster clear so everyone kind of knows who's working on what, and we'll share this so it's really clear. So design updates, I know we kind of decided things like we want to have a long style drivetrain instead of like a square chassis, and I think we're a little uncertain on cube and cone, but that's okay. And Sawmill's going to give us an update, and then eventually we'll circle back to Sid. So Sawmill, are you ready to do your stuff?
Yes, I'm ready.
All
Let
right.
me put
I'll
a.
stop sharing here.
It is loading. Okay, it should be here. So my goal for this one is just to give a general concept of a design for a lift that we can use in this game. And the one that I've come up with as such, so this component here, that's just the robot base. And these three are all linkages in a bar. Now, over
Sorry
here,
to interrupt,
yeah.
Sawmill, but
Mhm.
on my screen, I see like just the grid, and there's just like a big black box covering the robot. I don't know if that's just me.
Yes, I see that as well.
Okay, let me try to make that not happen.
Okay.
Now how it is? How does it look now?
You're not sharing your screen right now.
Yeah, you're not sharing it.
Okay, now it's. Okay, is it visible now?
Yes.
Yeah.
Now it is good.
Excellent. Sorry about that. Thanks for letting me know. As I was saying, this is the robot, and the arm is made out of three linkages. This red one will just be the intake, so whatever claw or flex wheel stuff we come up with. Now, the way it works is that only one joint has to be powered by a motor. So for example, let's say this one is powered by a motor. You can see that the arm comes. It can very easily, like very compatibly reach to the cube scoring location for middle and high. So all these arm distances can be real life distances because that's how I've made it. And so we can have like general dimensions. Obviously for the cubes, it can do the same because cubes can be dropped from a little higher and it should be fine. So that's what I have so far. Some pros of this design is that, like, first of all, it can easily and legally reach to all the scoring locations because it will be under the 4 feet restriction. And it allows the robot to be skinny because all you need that's more than the width of the game piece is just 3 more of, whatever tubes you decide. Then it also is like quite simple. For example, in programming, you only have one electronic motor group to control, which instead of like multiple joints, each having a motor or some pneumatics. And it's also easy for the drivers because the preset values is just how much the motor has spun. And also for building, you only need to build the motors or whatever in one area, and the rest of them are powered by chain. So it's like a chain bar. Now, obviously, there are some gear ratios on this, which, if you want more detail, you can message me and I can tell you all the gear ratios and all the length. I can also share this document. And then nextly, it also has a lower center of gravity because especially when you're driving around, you can keep the robot in this configuration so that when it's like this, you don't have a very tall arm or a very tall linear slide. Also, it's strong because you don't have to do any telescoping stuff. Since these are like all bars on one side, obviously you will mirror it on the other side of the robot, so you can brace it. And from this, we used chain on last year's climber, and I think it worked quite well. We didn't have issues with the chain itself, so that's why I think it would be strong enough to use some kind of sprocket ratio to have an arm go like this. Is there any questions about this design?
So it's like a virtual 4-bar kind of thing, like
Yeah.
a chain run 4-drive.
Correct,
4-bar.
yes.
Yeah.
And then,
Okay.
like with the 4-bar, of course, it's not one of those parallel ones that we use mostly in the VEX. It has these ratios to get it nicely done. And it can be tuned, like the design is fully parametric here, so you can change any of these parameters if anyone wants to experiment with that. Any other question about this?
Did everyone watch the video about virtual 4-bars? Because this is a bit abstract if you haven't understood the concept of those. And that's okay. I encourage you guys to go watch those videos and get some concept because this one's a little hard to visualize. and that's fine. It's hard to build too. I think a few teams have looked at this in RI 3D, and we should study those carefully to see what sort of issues that they were having before we get really excited about it, to make sure we understand the ins and outs. But yeah, I think this is a really good mechanism to think about and really consider carefully. So,
Do you, Samuel, do you have a secondary, like an intake to bring it into the robot before you deliver it to the goal? Or how do you pick up pieces, I guess?
So that would be with the claw, which is this translucent red box. For that design, my imagination would be something that with flex wheel spinning inwards. Now, regarding like a primary intake that goes on the robot, yes, that could be possible.
So the chassis is open in on the goal side, so there's actually a hole for the
Correct,
for the
yeah.
pieces to be in. Okay.
That's a possibility. If we don't want to add the extra complexity of an intake, it just could be a hole in the chassis with, I don't know, sloped sides. That could also work. Or it could just be that this red box, like, I don't know the dimensions of our intake. This one was just set like very abstractly. So perhaps if we do make an intake, it could extend all the way out to the chassis, and we might not need a secondary or primary
Have
stage.
it flip down or something. Keep it in perimeter and then flip it down.
I
we
have
have
an example of that from a previous year's robot, if you'd like me to share my screen.
Sure.
Here. So this is Team 971. They've done a bunch of like really crazy stuff, but I think the intake that Les was talking about, kind of like this, to like pick up cubes, or I don't know how cones would be picked up with this, but definitely they used this in 2019 to pick up the like cargo, like balloon things, and the cubes this year are pretty similar to that. So that's one of the things. And then also their 2018 robot was kind of similar to what Samuel was talking about with the chain 4-bar. Except they ran this whole hinge off of a separate chain. So it was like a powered 4-bar, like virtual 4-bar, which doesn't really make sense, but they did a bunch of like really crazy gearing stuff over here, which is, I don't think, something that we would attempt or be able to pull off super successfully. And then here's another example of like that intake you were talking about like a flip out sideways intake. But yeah, they've definitely done some really cool stuff, and they publish all of their designs, so it's nice to look at.
Mm-hmm. Yeah, I mean, the main thing about my design was not really about the intake. It was just about the arm geometry and any sprocket ratios to do, because I think the main advantage of the design I just showed is that it's quite simple in that you only need one actual motor group or power system at one point.
Mm-hmm. And I think this year a simple mechanism will be nice because it'll be lighter and faster.
Of course, yeah. Like, I was just comparing this to the one that we were discussing before about the ThriftyBot elevator, and I found this to be more suitable because of that area. Also because you don't have like many other mechanisms to deal with in that thing where you have to increase one stage or increase the next. In this one, you just turn the motor to 40 degrees and it should go to the middle position or high position like that.
Yeah. Also, telescoping tubes are crazy expensive. Yeah, I know that's a different consideration altogether, but
that's true.
Yeah.
No, it's a good one because we have to source the parts, and I'm sure right now the Thrifty elevators are in very high demand because every team is looking at those, and even if they don't use it, the good teams have all ordered that stuff, and so it's already hard to find. And the things to really think about is I guess boomstick or broomstick. That design uses a Thrifty elevator. It looks very clean, but as soon as it takes a big hit, a lot of those elevator components are going to bend, and it might not work quite as well as people think. So it's not just about simplicity of the mechanism, it's also about robustness when things go wrong. We learned that lesson with the climber, where, you know, our first event of climbing, we had a bunch of stuff go wrong. Stuff was just constantly falling apart. We figured out how to make it more robust. And once we made those small improvements, it really became a lot more, efficient and reliable. So we got to think about all those things as we're looking at these mechanisms. What's going to withstand a hit from another robot? What can we quickly fix without having to source any really complicated custom parts? So everybody's welcome to look at this, but I think we need to have eventually a pretty dedicated mechanism team that just focuses on the arm, and then maybe a separate team that just focuses on the intake portion. So if one of those jumps out at you, let me know. Obviously, we should have at least one person that's pretty good at CAD that's on each of those sub-teams, and then they will be kind of working with Sid to have that mechanism integrated into the master CAD assembly. Any questions about that process? No? Okay. Sid is not going to be on one of those teams. He's just going to be kind of overseeing and making sure that all their stuff is going to fit into the overall robot. The one thing that we are looking at is just drivetrain dimensions, and I think that's going to be a big one that we need to look at really carefully and have Sid decide on what the final dimensions are going to be, because that's what we're going to try to stick with. And then we're possibly going to make it, I guess the discussion was some switch between a kitbot and a swerve if needed. So if for some reason swerve just flames out and we can't get it working, we will take those dimensions and just have a kitbot that will almost insert into the exact same drivetrain dimensions, and then we can continue having a robot that's functional and can drive. That's, I think, the very tentative plan at this point.
I think another advantage of doing like an arm would be the ease of mounting, I guess, because for an elevator, you would have to have a lot of bracing points. Like, for example, the Cranberry people, they had like 2 mounting points that were very specific to the kitbot on the back of their robot, whereas like an arm could be mounted to like some extrusions just running across a robot. Whether that's a kitbot or a swerve really just depends on what's going on. Also, by the way, Samuel, you're still sharing your screen.